I am Vikaman from AML department. So today I'm going to talk about the topic on Linux fork, wait and execute. So before going into the program, let's have a short review or a quick recap of what is fork, wait and execute in the Linux. So fork is nothing but it's a copying of parent data to a child data, like the exact replica or duplicate of the parent data to another location. So generally, the duplicated or replicated file is generally known as child file. So this may done by the making the new child process an exact replica or duplicate of the parent as they copy the parent stat heap data and then exec. So as I said in this paragraph, the two processor executed the same program text, but they're having the separate copies of the stack, data, heap, and segment. The child stack, data, and heap segments are the initial um, exactly duplicates of the corresponding paths, the parent memory. After the fork, we can able to modify or make the changes in the parent process such that we can able to reuse it again and again. So while forking, we'll be able to get a process ID. The process ID is just nothing but ID which is recognized as the process has been taken from it. So the child process ID also it is there and a parent process ID also it is there in general. So the fork has three condition, three processes we can say. First, if it succeeds, then the parent process ID will be greater than 0. If it succeeds, then in the child process ID it will be equal to 0. If it fails, it will be less than 0. Then there is no child has been formed in that. So exit function. Exit function, as in general, we know that to terminate or to exit from a program. So it also has some range of 0 to 255, but the greater values can be specified in 128 can be cause confusion with the cell spec. So another function in the main that execute function. So loading of a new program of by any calls is commonly referred to an execution program, which is nothing but executing a program means we are running a program on a compiler or interpreter such that it gives some output to us. Execute to have some different functions with different arguments and environment with its parameters. So last but not the least, the wait process ID. So wait is nothing but a function is used to wait one of the children of the calling process to terminate. The returns the termination status of a child that is in the buffer point back to the status. So this wait function will be used to the many areas like during a process, if one child process has been taking part in the process, so it makes the upcoming children fork or um execute such that it can be able to form a line for them. Mm, Let's get into the program 1 second. One second. As this is a C program which used to print the process ID and the parent process ID using the Linux API calls. So for that, we need to include a stdio system slash types.h as a unit standard, then main function with PID underscore T process ID. So this is a variable to store the functions process ID and the variable to store the parent function process ID. For that, we are creating another variable. So get PID will be returning the process ID of the calling function. So this will be returning it and it will be printing it. So as it has been written in this compiler, what's in that file, and we get the process ID as a 9678. One second. Oh, sorry, we are in the wrong. So this is the program which I need to be showing. Hash included stdio, hash included slash type slash h um uni standard.h and initializing a main function process ID, parent process ID, and getting the process ID using get process ID function and get parent ID processor. Also, it's a function used to get the parent process ID and we're printing it. So this is the printed final value which has been shown. The process ID is 96 and 97. So the next program which we need to see is that the program for creating a new process using a Linux API system call using fork and execute function. So one second. So as for this, we need to again create a process IDs. So PID fork, which used to give the value for it, fork function. And if PID is equal to 0, then I have the process ID prints. And if PID is not equal to 0, then it prints the parent ID. So as this, we can able to get it. So in this, I am parent. My process ID is 6,800. So this 6,400. So parent ID is 6,834. So last. So this is the last program to execute the function. So one second. So the last program is to execute the using execute function. We are using a main int body such that int of status, so printing of the printf value, and execute a cl which used to print values, and wait which used to wait for the process IDs to be taken. So they're printing the excited with the print value, the status. So this is the output for it. Children excited with status of 0 done. Running a piece with excited allow with the path specified. So this is the function has been executed using execute function. Thank you.